Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Can hear me?
Yes.
Alright, so inshallah today, hope all of you are in good health and be grateful of all the blessings that Allah have given us, including able to breathe and still sane, waras masih waras lagi pada hari ini. Sometimes kita take for granted kenapanya nikmat kewarasan. Sekejap saya nak nikmat kewarasan. So bila Allah tarik nikmat waras tu barulah kita barulah macam kenapa macam waras tu, for example you can think clearly, also a nikmat. You are not in very deep mental illness, also something we need to be grateful for. And we are healthy not only physically, sakit mana kita sihat badan, tubuh badan ni, kita juga sihat akal kita mentally and hopefully spiritually lah juga. Cuma spiritual ni payah sikit nak tahu, hanya diri kita je tahu iman kita ni macam mana sekarang. So and hopefully kita akan sentiasa kemaskan iman kita lah dengan minimumnya praying 5 times a day, and then top up with other sunnah, because yang fardu ni pun kadang-kadang kita tak khusyuk 100% kan. So maknanya ada banyak lompong sana sini, kita kena top up dengan benda-benda sunat so that Allah redha pada kita, so Allah akan jaga hidup kita. Simple je. Allah sayang kita, dia akan jaga kita. Tapi kalau kita tak menunjukkan kita sebagai hamba dia, macam mana Allah nak sayang kita, macam mana Allah nak jaga kita? Walaupun dia sayang kita kan, tapi dia nak kita, orang yang pergi pada dia tu lagilah dia akan jaga. Alright, so today we'll continue with the question on lasers. Right, Afiq, are you ready?
Yeah, and there's like parameters.
Oh yes. Okay. I think let's start with that one first. I give you. Can you share your slides and you can start presenting. Only 5 minutes maximum. Okay. Kucing dengan mouse.
So let me continue. So there are a lot of parameters of lasers, and everyone have different opinions on this. So what I try to conclude is that these are three most important parameters of lasers. The first one is wavelength. This is because of it depends on the materials that are used for laser semiconductor fabrication. And secondly is the power, which is in between light output and current. And the three is the spot size, which is the maximum energy density that can be achieved when laser beam power is set. But when we are talking about laser the semiconductor laser, there are like another things that we need to consider also. The first one is the output light versus input current curve and threshold current. And what is this is that as you can see from here, this is the output light versus injection current. And this is also, as mentioned earlier, one of the parameters of laser, which is the power. And the thing that we need to note is that first, what is threshold current? And then, so the threshold current is here. So the thing is that before the threshold current is passed through, below this, what would happen is that it would do spontaneous emission. Only after the threshold current is passed, then only stimulated emission would be going through. And the threshold current also, it differs based on materials. And when we talk about threshold current, there is also threshold current density. the lower the threshold current density is better, because uh, which means we want to lower uh, minimize the spontaneous emission as much as we can. Since if we manage to uh, increase, using the lesser power to induce lasing action, it is much better, since we are the target that we want to do is the laser. And secondly, the slope of the Li curve. And for this slope, the higher gradient is better. The higher gradient is better, since we can have higher light output with a smaller current. And then secondly is the characteristic temperature. The characteristic temperature, as you can see on the right side, the graph, um, this is the Li curve also, but the temperature that um, it reacts is different. So the higher, so the temperature here at 20 degrees has higher efficiency compared to at 80 degrees. So this is also different based on the materials. The data that I found is only for this graph, which is, if I'm not mistaken, gallium indium arsenide. And so I think that's all for the parameters. And previously, Doctor also asked me to find again the reflection. So this is another reflection that I could find. Ya ayuhan nas qad ja'akum burhanum min rabbikum anzalna ilaikum nuram mubina. This is from An-Nisa ayah 174, which means, O humanity, there has come to you conclusive evidence from your Lord, and we have sent you down to you a brilliant light. Light here can mean a lot of things. It can mean everything, which one of them is including laser. But the one most important thing is that from the Surah An-Nur ayat 40, أو كظلمات في بحر لجي يغشاه موج من فوقه سحاب ظلمات بعضها فوق بعض إذا أخرج يده لم يكد يراها ومن لم يجعل الله له نورا فما له من نور. So to summarize this ayah is that one thing that we must put in our heart is that we need to always pray to Allah, so that Allah bless us light in our life, in our heart. Because the thing is that if Allah wills it, Allah would not bless any light to anyone in their heart. So we need to always pray for Allah for this. I think that's all from me. Thank you.
Okay, thank you very much, Shafiq, for the extra information there. And now I open to the floor for any question. Who wants to start first? So this is an important topic. You better ask question. Unless you say you understand everything. Silakan, who wants to start first?
Hello?
Yes?
I have a question. Can you explain again what is the mechanism or reason behind why the light from the laser is one directional compared to the LED light, which is LED light is not one directional, is like the light is produced in all direction, right? So what's that make LED? What makes that light from laser is one directional compared to LED?
Okay, let me share my screen.
Good question.
So let's go through this part. So what makes laser one directional is that, so they have what we call optical resonators. So from this, we have so from this image, as you can see, we have HR stands for the highly reflective surface, which also act as a mirror. So we have we have like five sides of highly reflective surface and one side of partial reflective. So the
Five
the
sides? Why
one,
five?
two, three, five.
Oh,
Yeah,
the top and the bottom. Okay.
yeah, top and bottom.
All right.
So we need the highly reflective surface so that every stimulated emission will be bounced inside, and then and then would only come out at this one part, which is a partial reflective surface. Since it's partial reflective, it allows the emission to be uh, only going through of this side of the material. So that's why it's called a one directional. Does that answer the question?
Okay. All right. It's okay. I might explain another way. Any other question?
Brother Afiq, just a small question. Why does the side that is partially reflective does have to be partially reflective? Why doesn't it have to be like a glass see-through?
That's a good question. I've been pondering about this too. But my guess is that because it's partially reflective, so that it could partially bounce back the some of the emission inside, and it would at the end of the day it would pass through here, so that it resonates with all the other stimulated uh, emissions.
Does that answer,
That
Anas?
that's
I think you want to add more?
no, that is my guess.
Anas, are you happy? Anas?
I can understand the reasoning, but just apa? Tak pasti sangat. Kenapa tak pakai kaca? Tu je.
Kenapa tak pakai kaca? Kenapa kena partly reflective? So Afiq, you need to explain in terms of why do we need the bouncing? Why do we need it to be bounced? Afiq?
Yes. So we need it to be bound so that the this it would be amplified, if I'm not mistaken. I'm not sure how to explain this. Yeah.
And it's the one of the most important part of the laser. So you need to explain that. So it makes
So,
go on.
I mean like since we want to we want to make the, since we want to condense highly if we want to conduct a highly light beam, so what we want to do is that we want it uh, to be very saturated inside before it goes through, and since
What do you
and
mean
then
by
it would also
saturated? What do you mean by the saturated? Is that the right term? Saturated. What's the right term?
resonated.
No. What's the criteria for it to lace? What's the criteria for a semiconductor p-n junction to lace?
We need what is it? Give me a second. I forgot the term.
Mana ni Afiq? Okay, next question. I will answer that later. Okay, next question.
I have a question.
Okay.
What is the application of the laser, semiconductor laser? Why it is important?
Yes. Okay, Afiq, can you answer that?
Yes, I can explain again the semiconductor laser. First of all, we
Make
want to.
it simple, Afiq, because you explained before when it doesn't understand, make it simple. What is the application? Just answer directly.
So the application, there are three major application. It can be applied in many places, and one of them is because it's small enough, it could be used and it we can allow for switching and modulation, and we can use them in fiber optic links as a transmitter. That is one thing. And then secondly,
Farhana, do you understand what fiber optic links means? Farhana?
No.
Okay, Afiq, you need to explain.
so fiber optic links is that, for example, in fiber optics, we need a transmitter and we need a receiver. If you guys remember, in previous in the in LDR in a
Photo detector.
photo detector. So photo detector, what that is a receiver for this fiber optic link. So fiber optic links is a is a way of transmission of data other than the normal copper cable. So what it uses is that uh, a it use a fiber optic or glass which capitalize on the total internal reflection to bring out to send the data through light. So the one of the one of the way of to transmitting this is by using laser.
Okay, let me answer simply. Basically, what Afiq want to say, you know, your house using Unify ke, Farhana? Ke tak?
No.
No, so you don't know Unify. Well, Unify is using fiber optic link. So Unify, that for you to get the internet, they are using fiber optic. So that's how you get internet access in your house. So how you can download video, you can zoom, you stream everything through fiber optic link. And this fiber optic link, you need to have a transmitter, you need to have receiver. Transmitter are using laser. Light, the fastest thing on earth, not on earth, in the universe, that the scientists have found out is it's light. There's nothing faster than light. You know, So if we can transmit in the speed of light, then the transmission be very fast. So that's why they are using fiber optic because we can transfer light through fiber optic. Basically, that's the answer. Maybe Afiq is very technical. So, technical is good, but also we need to learn to explain in terms of apa layman words so that people can understand. So laser have many applications, not only fiber optic link, not only the one that Afiq use. Everyday life, even if your Blu-ray, DVD player also have a laser over there to read the DVD. Use laser. So I think everywhere but nowadays the thermometer that use the thermometer gun, some use laser, some use. That's why you cannot look at it directly into your eyes because it can damage your eyes. So medical, you can do any surgery using laser surgery. Mata pun you can do, yang apa tu, yang tak payah pakai cermin mata tu, pembedahan tu.
LASIK.
LASIK. LASIK pun nama dia LASIK pun because laser. So thanks to laser, many things have evolved, right? That's why it's important to understand laser. But I don't know whether you understand ke tak lah. Lepas ni kita tengok dalam exam lah nanti. Okay, more question?
Yeah. Can you explain further the difference between LED and laser?
So, share screen. The difference in between LED and laser is, first, laser is highly monochromatic. It's only have one. It only have like very small line width of how to say wavelength. So usually it highly chromatic means it's only have one color compared to LED. LED emits a lot of colors, which is.
But they say I buy an LED, the blue LED. Why is it only one color? And you say there are many colors.
And another reason is that it's because of one of laser also laser also are using the stimulated emission as a it's capitalizing on the stimulated emission compared to LED is using a spontaneous emission. So because of that particular stimulated emission, we only modulated at a single frequency compared to LED. It have even though it emits like what we can only see in one color, but it only but the what to say?
The spectrum.
Yeah, the spectrum is much larger compared to laser.
Is there more?
What else? And LED doesn't have optical resonators. It doesn't have optical resonators. It doesn't have a highly reflective surface. Yes.
Any more?
No.
Haris, are you happy with the answer?
Just the monochromatic part.
Okay, what do you want to know?
Because some LEDs are also only produce one color. So what makes it the difference again? The monochromatic part?
So the monochromatic part it is coming um, from the stimulated emission, which is which means like for this to happen, stimulated emission to happen, it need to be highly in phase, and it needs to be highly in phase. So it needs to be the same frequency. So when it hits the this at the same frequency, it would become more. Uh, so the majority of the light that are produced by the laser would be at that specific spectrum, which is like a very small spectrum, which is highly monochromatic. Even though it's like very, you can say like, even though it's a red laser, it's this small compared to LED laser, which is has even higher spectrum, because it doesn't because the LED itself doesn't need to use doesn't need to have stimulated emission as its main source of light.
Macam mana, Haris?
Ya, okay, dah faham lagi lah from before.
Okay, let me answer the question. Monochromatic. So I think this preliminary, or after this, all of you, I think what you need to do, go and Google videos on laser. There are a lot of good videos on lasers, which they explain because kalau tak, saya rasa lah, if I ask you, I think you are not clear what's the difference between LED and laser. Kenapa suddenly? You know what's the difference, the color? If I bring, can you stop sharing jap ni, Afiq? Fokuskan muka saya. Fokuskan everybody. So if you buy a laser, right? This a piece of laser and a piece of laser and a piece of LED, and it comes out light. Do you know the difference, right? You have seen a laser and LED, right? All of you, have you seen? So what's the main difference that you can see?
The directional light.
Yeah, so you can see the laser is like only one direction. That's why it can be used as a pointer. The LED becomes, it will be have like a, like a ring, macam dia bulat kan, so it become bigger. So it's the what do you call it? The rays are going everywhere. What's the other thing that you can see? How about the color?
Light intensity.
So laser is very bright, right? And LED you can see lah, you can look with your eye, but laser never ever put through your eyes. Then it will damage your eyes. So one of the reason, because if you can see, it's very bright. Number one. Number two, very bright just means that you have more recombination rate, right? So you have LED, you have laser. Laser means you have a higher recombination rate. But not only that, LED, if you pump a lot of voltage, you pump a lot of current in, you get a lot of recombination. Laser, you pump a lot of current in, you also get recombination. So the number of recombination will give out number of photons. Number of photons will give out the intensity. However, the difference with laser is that I will cut short because I have this question for Afiq later. So basically in the end, the laser, what happens is, why is it monochromatic? Because in the end, if you see the spectrum, we have a machine, we are on in PKP, otherwise I can bring you to my lab. In our lab, we have a machine that can, called monochromator. The name of the machine is monochromator, and this monochromatic, light. Monochromator basically is a machine that can measure the light intensity plus the wavelength. They will tell you what kind of wavelength. Wavelength, for example, 452 nanometer, that's a wavelength. So for laser, the line width, if you can see the spectrum, is actually very sharp. It means that there's 452 is the peak wavelength, and you can only have like 451 or 453. That's all. I mean, the range of the wavelength that comes out from the laser semiconductor. However, for LED, if it's the same material, the peak will be at 452 nanometer as well. It's the same color, for example, blue. But with LED, you can also get a range. So it can go from 445, 446, 447, you know, the wavelength. It's a broad. So although our eyes are not capable to differentiate every single wavelength. Saya rasa kalau kita boleh differentiate, kita gila kot. Because if you see blue, you have different kind of blue. So because when you say blue, if you see this blue, right, you see one color, right? But actually from here, there are many wavelength that comes out. But Allah is merciful. Dia tak nampak. Our eyes cannot differentiate between certain wavelength. But for laser, it's very monochromatic. That's why it's very useful for data transmission, because we want only one wavelength and we use that wavelength. Kalau LED ni banyak wavelength, pening. Tak tahu kita nak transmitter, photodetector nak detect wavelength mana. Okay, although our eyes can only see one color. Haris, you understand? Mana Haris?
Yes, madam.
Okay, so that's monochromatic. Monochromatic means it's only one ideally one wavelength lah. Tapi dia ada satu dua lah. Spektrum itu dia tak, nothing is perfect. Dia ada extra sikit because of the temperature. Okay, any more question? Group mana kita tanya? Semua tanya dah? Semua dah faham? Oh, Muhammad angguk lah. Saya tanya Muhammad lah macam tu soalan. Boleh? Dah awak faham? Be careful lah. So all of you understand ke tak ni yang lain sebelum saya start tanya soalan? Kalau saya rasa prove me wrong. Semua faham ke tak? Ni Azuddin, do you understand?
How it work? Tak clear sangat.
Dah kenapa tak tanya? Apa ni? Sakitnya saya. Tanyalah kalau tak faham. Alah, okay. Ask properly the question to Afiq.
Afiq, can you explain a little bit more regarding how the the laser works?
Okay. Make it clearer.
Because how laser work is quite big. Do you want me to explain everything, or energy band diagram, or just in general?
Regarding the stimulated emission and where the refractive slide like that. You get it? Or
Yes, I get it. Let me share my screen again.
Can you share it very fast? Can I explain it quickly?
So,
I think we want to do solar cell today.
Okay, yeah. Okay, so basically, how does laser work is that we have a P-type and N-type. So how the laser is using and this P-type and N-type must be degenerately doped, which is it must be highly doped until the Fermi level become for the N part it will be more than.
You want it to be degenerative? Is it due to doping or due to population inversion?
Because we want the recombination to be as much as possible. So the population inversion needed these two, as well as the forward biasing current.
Yes, but I don't think because when you Google degenerative, you can get degenerative from two. One is by doping, another one due to population inversion. I think you
Is
get
it this? Sorry. Can you
can I?
repeat again? Previous sentence.
This degenerative, yes, you need to have a lot of free carriers. Basically, degenerative means the fermi level is inside the band, so not in the gap. How to and this is important so that you get a lot of free carriers. Therefore, there will be a lot of recombination. How to get this? So if you Google this, normally normal case is you highly dope, but not in terms of laser. Normally you get this degenerative. Yes, you need to highly dope, but not necessarily anti-degenerative. You can also get this Fermi level to be like that using population inversion, which is what is my question. I've written the question. What is population inversion, which you didn't explain?
So
And population inversion is the key for laser.
as far as I understand, population inversion is when you supply a high current. When you supply a high current inside uh, forward biasing current, and so there is a lot of electrons will be on the uh, conduction, on a lot of electrons will be on the conduction band. So therefore the recombination would occur in very high rate because of the electrons that are being supplied by the high current input.
So my question, okay, so just to check your understanding and everybody's understanding. So if you say so, if you increase the current and then you get population inversion. So let's say I want to make a laser, I increase the current, but I didn't have reflective coating. It's not highly reflective. Can I still get population inversion or no? Payah sikit lah, awak fikir sekejap tak apa. You can answer this, it means you understand.
No,
Know what?
I mean without highly reflective, the population inversion would still occur because
Will still occur or not occur?
It, from my understanding, will still occur.
So you can still get population inversion without the apa nama ni, the reflective coating the high reflective coating, right?
Yes.
So why do you need the so then why do we need the coating, the high reflective?
The highly reflective coating is that so that because we want I was thinking about this earlier, but give me a second. I actually lost track.
Boleh ke?
So highly reflective coating is that so that we want to confine the photon in a as much as we can. So it's basically the highly reflective coating is to build up laser intensity, and then to build up laser intensity before it goes through the partial reflective and send out the high beam of energy.
Okay. I think based on your understanding, it's okay, but I think you need to read a bit more, and the rest of you regarding population inversion. So this is the keyword, brothers and sisters. We will not have any class. You go need to go and find out, go and read video. The key for laser is population inversion. You need to understand how do we get population inversion. And the population inversion has to be in semiconductor laser, because if you Google, population inversion ni banyak jenis. Ada yang jenis yang laser gas laser. So sebab tu kot bila banyak tu kita kena tapis banyak kat internet tu. But the best is go to read textbook of the semiconductor laser, just on the laser, and but dia tak ada video lah. If you want to see video, sometimes they make a good video on the, if you find a good video, you can share in the Telegram. So the rest can also benefit. So okay, tak apa. Nanti saya explain bila saya dah habis tanya soalan. Ada lagi soalan? Basically how the laser works, it has to do with population inversion, stimulated emission. Then the next question I will ask, if I'm a student, what's the difference between population inversion and stimulated emission? Can you answer? Not you, Afiq. Nak tanya orang lain yang tak tanya soalan ni. Hazim, can you answer that? What is the difference between population inversion and stimulated emission? Hazim, tak dengar?
I think I don't know the answer for that.
Okay, so you'll find out, right? Go and find out. So, semua faham LED kan? All of you understand LED. Laser basically is an extension of the LED. So now you need to understand what is stimulated, what is population inversion, what is, because in the parameters that I mentioned, it's about threshold current. Why in laser you have threshold current and in LED doesn't have threshold current? What is the relation of the threshold current to the stimulated emission? Afiq ada jawab juga sikit-sikit tadi. Tapi I'm just giving this, write down, go and get the answer. Okay, my question to Afiq. Yes, I'm trying to think. How does LED? So basically, how does the LED works is actually not very clear. And apa nama siapa tanya tadi? Ni Aizuddin also tried to ask, but it's still not clear how actually the semiconductor lays. The keyword there is population inversion. You need to push the PN junction into population inversion. In order to do that, Afiq tried to explain whereby you need to increase the current. That's why if you look at the graph of the LI graph, light versus intensity graph, yang tadi tu ada threshold current tu. So that's why you keep on increasing the, boleh buka tak graph tu jap? Yang ada threshold current graph tu. So basically, benda sama, awak ambil sekeping PN junction of a LED, it can become a laser. Benda sama. Tapi the difference is, maknanya the structure, it can be the same PN junction structure. The only difference, you drive the laser to a higher current. So you pump satu. To increase the efficiency, not only pumping, you put the reflective coating. Okay, so kalau tak reflective coating, dia boleh jadi laser juga. Tapi you need to have a lot of current. You need to pump because you need to go to population inversion. Buat besar sikit, kenapa saya nampak kecil ni? Afiq? Sebab tak nampak kecil sangat. So you can see on the left there, the ITH tu ITH is the threshold current. It's very important, that parameters for a laser. So a good laser will have lower threshold current. Kau boleh nak zero lah. You masuk je current, lace terus. But this means that you need to put a certain current before it starts to lace. Okay, which is for it to be in stimulated emission. So kenapa saya cerita ni tadi ya? So jadi so when you have population inversion, and then the population inversion is the process to get a very high free carrier concentration, then you have recombination. When recombination dipanggil stimulated emission. Emission is actually recombination. Stimulated because because of the apa nama ni, population inversion tu, bila dia recombine, dia tak akan recombine random macam LED. Dia akan follow incoming photon. That's why in the end you need the reflective apa namanya coating, sebab you nak ada photon the same wavelength. Dia macam bounce around sama jenis photon wavelength sama. So bila yang lain recombine, dia akan melekat, dia akan jadi sama. Macam tu lah, bukan perkataan melekat tu tak pakailah dalam tu, saya nak cerita melekat ni sebab biar faham. Basically when it recombines, it will follow the incoming photons characteristic. And the incoming photon is the one photon yang bouncing inside the laser diode. Then when it comes out from the what I call it, the laser diode, it's actually monochromatic, in phase, single phase lah. In phase maknanya dia tak ada yang 180 degrees semua, and that's in phase is important for communication. Benda tu penting. So that's why if in communication you use laser lah, kita tak pakai LED. Tapi laser ni dia lagi mahal, and to operate also at a higher current. Maknanya lagi you need more battery to operate a laser compared to LED. Okay, can stop sharing. Okay, I think enough question by by everybody. So apa nama ni? I think that's enough for me. So let's go to solar cell. Where's the team? So thank you, Afiq, for the presentation. So the rest of you can also find out for nanti cari sini jugalah. Afiq boleh share video-video yang, sebab laser ni memang tak straightforward. Okay, group solar cell, you have 20 minutes from now.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My group going to explain about solar cell. This is my members group, and this is our agenda. I will explain about brief introduction and then working principle, and then Azan will proceed with different type of solar cell. Performance parameters will explain by Munirah, and next will be explained by Mija. Next. So as for a brief introduction, solar cell is a device that converts solar energy into electrical energy when the device is exposed to sunlight, and we call this process as photovoltaic effect. The diagram shows the basic layers in a solar cell. Firstly, we have glass. Typically, we have glass for the first layer, and then we have anti-reflection coating, and then we have metal grid. Next, we have semiconductor. We usually use silicon with the N and P type, and lastly, we have metal plate. Next. So in solar cell, the important part is the PN junction. The left figure shows the where the PN junction in equilibrium state. What means in equilibrium state is that where the PN junction is in dark situation, or where there is no sunlight or light is absorbed by the material. And then for the right figure shows the semiconductor when the light is exposed. We can see that the red dot is represent electron and the blue dot represent holes. So when the sunlight is exposed to the PN junction, it will generate electron pairs in both sides of the junction. And we can see that the minority carriers in P region, which is electron, is increased, and same goes to the minority carriers in N region, which is holes, is also increased. Next. Now let's see the energy band diagram for the solar cell. We can see here that to generate electron hole pairs, we need the photon energy to be more or equal. In other words, the photon energy must sufficient enough so that the electron can jump from the valence band into the conduction band. And then the electron is drifted into P region. Now let's see if the semiconductor is in open circuit. What means in the open circuit is that there is no external load between the PN junction. It means that open circuit is have no current flow inside the external contact. We can see that from the video. Carriers positively charge the P region with holes, and same goes to electron that will negatively charge the N region. And then the charging will create an electric field which is have opposite direction to the Boolean electric field. Therefore, the net drift will decrease until the net drift is equilibrium, so no net current is involved. Let's see if the semiconductor is in short circuit. Short circuit means that, next. Short circuit means that the external load is connected in the wire, in the external wire. During this short circuit condition, minority carriers, which is electron, will drift from the P region to the N region, and the electron will diffuse into the metal contact that is attached to the N region and to the P region. And then electron will move across the P region, and at the same time, host minority carrier in the N region will drift into the P region, and the host will recombine with electron in the P region. You can see here the difference between energy band diagram difference between open circuit and short circuit. We can see that with open circuit there is less voltage put in compared to the short circuit that has higher voltage put in the band diagram. Next, we explain by the Azan about the next slide.
Proceed to the type of solar cells, just like we have explained it just now. Solar cell is a solid-state electrical device that convert the energy of light directly into electricity by the photovoltaic effects. So the difference between the type of solar cell is due to the semiconductor material that used to produce it. But the most and widely used monocrystalline, thin film layer, hybrid solar cell, and also there is a multi-junction solar cell that I will explain later. All of these types of solar cell are commonly used as a solar panel. So as you can see in the slide, there is a picture of mono and polycrystalline. So for mono, the solar cell is in black color and the square is cut off, while the polycrystalline is in blue color, while the shape of the square is without corner cut off. The difference between this mono and poly is due to the constructions of the materials. Both of the mono and poly are used crystal silicon, but for mono, the single crystal formed using Krasky method, where the seed crystal is placed into a vat of molten pure silicon at a high temperature to produce large crystal, and then it sliced into thin wafer. While for poly, instead of pulling out the silicon seed crystal, we let the whole vat of silicon cool. It's like monocrystalline is like a candy where we pull out the crystal seed, while poly is like just we melt the chocolate. Okay, so the efficiency of mono is higher than the poly. It is because mono is made out of a single crystal silicon, which is more pure, so the electron is easy to flow. However, poly, there is some impurities due to the constructions of its materials, where it's built multiple crystal form that make it harder for electron to flow. And then when the efficiency of mono is higher than the poly, it will require less space than the poly. Normally for mono, normally it needs 60 cells for mono solar cell, for mono solar panels for residential use. Nevertheless, mono is more costly than the polycrystalline because of the way that mono panels are manufactured. Next, the thin film layer is made up by depositing one or more thin layers or thin film of photovoltaic material on a substrate such as glass, plastic, or metal. This cell within panels are roughly 350 times thinner than the crystalline wafer. It is suitable for low capacity installation because thin layer film has low efficiency. Another one is hybrid solar cells, combine advantage of both organic and inorganic semiconductor, where organic act as an insulator and inorganic act as a conductor. The hybrid photovoltaic also a low cost but suitable for scalable solar power conversions. Next. Okay, here is the multiple junction solar cell, which is there are multiple PN junctions that can induce a flow of electricity, while single junction only has one junction that can induce a flow of electricity. Single junction is just like a solar cell that I explained just now, like a mono poly thin layer film. So for multiple junction, they use separate semiconductor all respond to different wavelength of incoming sunlight that make it more efficient than the single junctions. As you can see at the materials part in multi-junction, they use 3 separate semiconductor. This one is for 3 junctions, gallium, indium, gallium arsenide, and germanium. While for single junctions, only one material, silicon. So however, it is not commercially available yet, but for sure the price is too high due to the material used, and the process to make it is quite complex. That's all from me.
Okay, next is the performance parameters. Performance parameters is what we want to see before we integrate any type of solar cell into our system. So the first one is about the short circuit current. Short circuit current is the maximum current that a solar cell can deliver without harming its construction. How we can measure it? By the short circuit the solar cell at the most optimized condition for producing the maximum output. The optimized condition here means the intensity of light and what angle does the light fall into the surface. So we can see uh, from the equation there, the max current density depends on the surface area exposed to the sunlight. The max current density is nothing, but is important if we ratio it with the area of the solar cell exposed to the sunlight or the light. Next is the open circuit voltage. Open circuit voltage is usually denoted by VOC as in the picture and is usually nearly equal to 0.5 to 0.6 voltage. It can be measured by put the voltage across the terminal with no load is connected to the cell. Actually, the open circuit voltage depend on the manufacturing process and the temperature, and not based on the light intensity and the area exposed to the sunlight. Next is the maximum power point. Maximum power point is the maximum power one solar cell can deliver. It can be get from the IV curve plotted with the short circuit current and the voltage that I mentioned previously. From the IV curve also, we can get the maximum current and the maximum voltage for a solar cell. Next is the fill factor. Fill factor is the ratio between product of current and voltage at maximum power point to the product of short circuit current and open circuit voltage. The fill factor is important to determine the power conversion efficiency of a solar cell. And finally, the most important factor of a solar cell is the efficiency. Like Isaiah mentioned before, the efficiency is mainly discussed, right? So how does we calculate the efficiency? Is by ratio the maximum electric power output to the radiation power input to the cell, and it is expressed in percentage. So the power input is calculated by considering the radiation power on the earth is about 100 watt per square meter. So it will be multiplied by the exposed surface area to of the cell, debited as A, and then the total radiation of our cell will be 100,000 ampere times area watt. Next, we proceed to Mirza.
Okay, so next is current technologies of solar cell. To achieve maximum solar to electricity efficiency at low cost, there are three types of highly investigated semiconductor material, which are the first one is crystalline silicon. This material is the most used semiconducting material in solar panel, where the theoretical limit efficiency is around approximately 29 to 30%. So to increase the efficiency of this material, the National Renewable Energy Laboratory is driving the development of high efficiency crystalline PVs, where they develop 3 to 5 multi-junction material solar cell with target efficiency of more than 30%, and also hybrid tandem 3 to 5 silicon solar cell. These are a new technology where it is believed to have a high efficiency compared to the traditional panel, which is below than 30%, which is a quite small efficiency. Another technology is 6 junction 3 to 5 solar cell that have reached an efficiency of 47.1% under concentrated light, and also silicon bifacial that can harvest solar energy from both sides of the panel with 11% more efficiency compared to the standard panel. Next is thin films. This material also one of the most promising PV technologies due to their narrow design, which is very light compared to crystalline silicon. Lightweight flexibility and ease of installation. There are 4 types of material are used in their construction. The first one is cadmium telluride, second is amorphous silicon, third copper indium gallium selenide, and the fourth is gallium arsenide. So how to increase the efficiency of this material? They are using the CHICS technology, which is copper indium gallium selenide, They adjust the parameter where you can varying the bandgap of the material, optimizing the value of this copper, indium, gallium selenide to increase the efficiency of this material. Cadmium telluride also can be used, but it has a toxicity concern, which is environmental issues. And the efficiency of this material has increased from 12% to 20%. However, between the silicon and thin film, silicon is more efficient compared to thin film. Next is perovskite solar cell. This one is one of the material that is believed can be another two material, but not being commercialized yet because it's still under research. As can be seen here, among the next generation solar cell that have garnered a great amount of attention because of due to its low cost in production. The combination of perovskite and silicon PV materials have shown a record efficiency of up to 28% under laboratory conditions, which is quite high compared to the other two materials. The advantage of this material is it is man-made material compared to the crystalline silicon because man-made material is low cost in production. If crystalline silicon, you need to process it first before you can produce a good quality solar cell. This material, as I've been said before, is not being commercialized yet because it's still under research due to some issues like stability and durability, the sensitivity to air and moisture, and also it has a toxicity issues, which is the environmental issues. Okay, lastly, is Islamization. Islam does not oppose development. That being said, development must be carried out in line with the framework outlined through the higher purposes of Islamic divine law, which is Maqasid al-Sharia, the best, the most suitable for Muslim, the most suitable guidance for Muslim to adapt. This is to ensure that development that is carried out does not pose any risk to mankind and the environment. So what kind of development? For our topic is the development of solar cell. So from solar cell, we get to develop a device like solar panels, photovoltaic cell, which convert light energy to electrical energy, which is a renewable energy that is collected from renewable resources such as sun, which is protect the environment as it derives clean, pure energy from the sun. So these are the framework to discuss about this sustainable resources, which is Maqasid al-Sharia. The first one is protection of the faith. Protecting the environment contributes toward the protection of the faith. If you do believe in God, you should know that it is your responsibility to protect the environment. Huh?
Finish time. I'll give you 30 seconds.
Oh, okay. Next is protection of the life. Then protection of the intellect. The environment become an important avenue for mankind to enhance his knowledge and intellect by observing his surrounding. So you need a good surrounding to enhance your knowledge. Protection of progeny to sustain the life of future generations. Protection of property. The natural resources found in the environment are considered as property that needs to be managed wisely and sustainably. Everything that is created by God on this world is for the benefit of mankind. Do not cause corruption on earth, but call on Him with fear and hope. Surely the mercy of Allah is always near for those who do good. In Surah Al-A'raf, verse 56. That's all from me. These are our reference. Thank you.
Okay, thank you, sisters. Let's open to the question. Before that, I just want to say the presentation are all good except for the how it works. Okay, that is the major part of the which I mentioned. It have to be in terms of energy Venn diagram. There's no energy Venn diagram. You didn't explain based on my criteria, right? So I know it's difficult to find energy Venn diagram in the internet explanation, but that's my criteria. It cannot be because the one that you've been explaining is regarding the structure. In the exam, if you do like that, you get 0 lah. So because you're not answering the question. So that's my comment lah. The overall is, the rest is actually very good. So sayang lah, just that part. You didn't read, I don't know, you didn't ask me or you didn't read the instruction properly ke macam mana ke. Okay, we open to question. otak I will give you 90%, but the rest yang bagus lah, the rest I like the rest very detailed, so then I cut marks lah. Sebab major part of the explanation is how it works. Okay, can I have question from the floor? Maybe if you can answer the question, we can increase marks more, depends. Okay, soalan? Brothers, sisters? Each group have the, so can you stop sharing? I want to see the faces of everybody. Answer question, ask question, otherwise I will ask you and deduct marks from your group if you cannot answer.
I have question.
Okay, Mohamed. So, siapa Mohamed?
Okay. Yeah. Can you explain again about the mono and poly? And then what type of solar cell that most commonly used in our country?
Okay. Who wants to answer?
So, okay. The difference between mono and poly is due to the construction of that material, which is silicon crystal. It's the difference is due to the construction. I mean the manufacture, how it's manufactured the material. And then the color of mono and poly is different also because of the manufacture of the material also.
So what does the colors mean? I mean, how can by using different color we can get different efficiency?
No. I mean the construction of mono. The construction of mono is where the crystal form of silicon using the Sokrasky method, where the seed crystal is placed into vat of molten pure silicon, and then it produce large crystal, and then we slice it. While poly, we just let it melt. So due to the construction, it produce a different color. Okay, and then the most commonly used is monocrystalline due to the performance. Even mono is costly, people will choose mono, but in real life, however, the difference of the cost is slightly different lah. So people will go to the performance. Okay, that's all.
Does that answer Mohamed? Are you sure?
Sure lah juga. Sebab you awal tu macam I'm not quite understand about the how does by using, because there are two type, right, mono and poly. So I mean that for the mono, how can we just like the Bija tutup mic Bija.
Sorry.
Okay, so mono dengan poly kan. Lepas tu and then by the what I don't understand is that the colours, meaning that the mono, the colours is just we can see from the slide is black and the poly is the blue. So how can they increase the efficiency? So that by what Azad explained is that by the construction is different. So I think that's answer my question.
Okay, basically it doesn't matter the color. The color just a byproduct. So the most important is the monocrystalline. They don't because the way it's structured is easy for, it's more, the mobility is high compared to poly. Poly you have more obstacles for the free carriers to move. Therefore mono is always that's why the efficiency is higher. However, it's more difficult, more expensive, requires more time to create monocrystalline solar cell. That's the difference. Polycrystalline is very cheap to make. So I think everywhere you can go, if you ask the question, Malaysia mostly will use polycrystalline. except for if the technology getting better and better, if monocrystalline become easier and easier to make, and one day all of us will be using monocrystalline. So it depends on the technology evolving. But if you buy on Shopee tu, awak beli kat Shopee ada solar cell lah, solar panel dah, tu polycrystalline lah, awak boleh beli tengok. Okay, next question. Who's next? Quickly.
I have a question.
Okay.
Does temperature affect the efficiency of the solar cell?
Okay. Thank you. Please answer.
I think temperature affect the efficiency of the solar cell because the temperature actually affect on the open circuit voltage. So open circuit voltage will affect the maximum power point, which will we will plot the max power point. So I think temperature will affect the efficiency.
So how does it affect?
How does it affect? Because
How? Bukan because, bukan why, how?
how does it affect? The temperature will, I think, will affect the open circuit voltage.
How does it affect the open circuit voltage?
How does it affect? When the temperature is high, the open circuit voltage will be high too, because because of the temperature will affect the PN junction construction. Is it answer?
50%. Boleh lah. Jawab daripada tak jawab langsung. Okay, so Elmai, try to find the answer, Munirah. How does temperature affect the ni, and answer in the telegram later. Go and find search. Okay, next question. Next question.
I have a question.
Okay.
Earlier was mentioned about the angle of light exposed. What does it mean?
Oh, angle of the light.
Ada orang lain nak jawab? Orang lain pula.
Sorry. Because this is under my topic.
Yeah, I don't care. So people answer.
I think angle of the light is about the exposed surface area. So so we need to surface area must be widely exposed to the sunlight so that the solar energy can get more or higher photon energy. So so that's why we need to have more angle so that the more exposed surface area on the solar cell.
You
Does
understand?
it answer your question?
Then does it matter? I mean, like in a bright sunlight scenario, in an open air, does it matter if we put like the solar cell, like for example, like in 40 degrees, 50 degrees, or is it like this or like this or like this in a scenario of bright sunlight in the middle of the day?
Answer.
Sorry, come again your question. You mean that when we construct the solar, we put the solar energy, the solar cell?
No. What I'm trying to say, because the angle of light, right? So in the for example, in 12 p.m. in bright sunlight, in the middle of bright sunlight, does it matter if we have like a slightly different angle of solar cell? Would it affect?
Good question.
I think in the situation with the bright sunlight, I think the degree of the solar panel, solar cell is not really important because it has most of the sun, area exposed to the light.
If
So
it's in the morning,
active in the morning, we have to take to make it more exposed to the sunlight.
Does that answer your question, Afiq?
Madam, can I answer?
Okay.
Okay, so usually before we construct the solar panel in any place, the engineer will determine, they will set an angle and in which angle we sunlight
Hit the
datang.
most. Hit the most.
In which angle that sunlight will hit. For example, solar panel in white area, so they have a panel that can control the angle of the solar panel. So the angle is changeable. Depends on the sunlight.
Direction.
Yes.
Yeah.
Okay, Afiq, are you okay? Boleh lah.
Okay lah kot.
Okay lah kot. Boleh lah, 80. Okay, then any more question? The time's up. So we'll, can you stop sharing? Solar cell is actually very important, brothers and sisters. The Malaysia solar farming in Malaysia is booming. Boom, around the world is booming. Even Petronas are going for solar farm nowadays. Okay, so that's why if you want to go and work later, you can use this course. Say I covered solar cell, so make sure you understand lah. You say you cover, dia tanya soalan how solar cell works, you cannot answer. And how? So solar cell is the country are going, they want to push the kementerian kementerian apa tu MOSTI and also kementerian energy ni would like to boost up to 30% of our electricity from renewable energy, and now they are going for solar farming. So that's why you can see there are more and more. So many companies are coming up, they need people to work. So it's good if you want to go to this area, bagus, go and learn a bit more on this. Then try to apply lah, so memang banyak kerja kosong. But make sure you understand lah solar cell. Tapi yang ni we are going to very minute which is solar cell. Kalau yang solar farming tu solar panel, dia ada banyak lagi electric circuit yang perlu kena mena. Tapi kita dekat bawah to understand how the solar cell works, which is also important as for an engineer to design lah. Tapi yang untuk yang solar farming tu dia banyak benda-benda lain. We were thinking to make a solar renewable energy course, tapi tak offer lagi kan. Be good kalau ada. Okay, so I think that's enough for today. I will give extra chance for this group to help your marks by next Tuesday, just on how the solar cell works using energy band diagram. Okay. Kalau screw up lagi, saya lagi tolak markah. So please go and find out. I know it's tak ada banyak sebab nanti kawan-kawan susah nanti nak jawab dalam exam ke apa. Kalau dia tak nampak benda tu. Also, it's good that she already explains, but I don't know how much you understand. Saya tengok tadi pun kurang faham. So but you can also push some apa nama ni video dalam Telegram tu lah, good on solar cell to understand how it's not magic solar cell, but solar cell is actually interesting lah, where you shine light, you get free electricity just by shining the sunlight. So how are we going to do it and how to increase the efficiency? There are a lot of questions or research going on how to increase the efficiency. But now even can you see the efficiency, the highest is only 22%. Very little, 80% lost. Where is the 80% lost? That's my question. Why only 22%? For example, LED laser is quite high efficient, maybe 70, 60. But for solar cell, now we are still in trouble. The world are still struggling because it's the commercial maybe maximum 20%. So 80% of the light hit the solar cell lost. Lost due to what? Maybe you want to explain a bit more on that. But this, if the technology getting better and better, we may not need to use the conventional electricity anymore. Tapi sekarang sebab 20%. Sebab tu dia very low efficiency. Okay? I think that's all. So I will give you a quiz. You can I will give you a 30 minutes quiz. Use on your own time whenever you want to submit before the end date is Sunday. So it's only 30 minutes. Time yourself. Make sure you don't cheat. Allah is the witness. And the apa ni? Saya janji quiz tu pasal apa?
PN Junction.
PN Junction.
PN Junction.
Yes, PN Junction zero forward reverse. Senang je. Saya rasa lah. So, but you need to be very detailed sebab saya suka potong markah. So make sure you don't miss anything. Okay, can we end the class with a doa? Somebody please. Tak keluar kita ni. Siapa yang minggu lepas? Yang hari tu lepas apa? Dah Afiq dah. So orang lain pula. Cepat.
Ya, Madam.
Okay, silakan.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Allahumma inna nas'aluka ridhaka wal jannah wa na'udzubika min sakhatika wan nar. Allahumma innaka 'afuwwun karim tuhibbul 'afwa fa'fu 'anna wa'fu walidina wa li jami'il mu'minina wal mu'minat wal muslimina wal muslimat bi rahmatika ya arhamar rahimin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Alhamdulillahirabbil alamin.
Alhamdulillahirrahmanirrahim. Thank you very much. Let's go to the class with tasbih kifarah and surah al-asr. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asr. Innal insana lafi khusr illa alladhina amanu wa 'amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr. Okay, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.